Hey Math 1B, I got a new lesson for you, starting out a new chapter. This chapter is all about the concept of factoring polynomials. So we talked about how to expand polynomials by multiplying. Factoring is kind of the reverse. Before we can jump into polynomial factoring though, we got to make sure we got basic skills down that you guys, we were hoping you guys would have learned in a previous math class. So prime factorization. It means, can I take an existing number and break it down into a series of multiplication moves where every single number in that multiplication series is prime? So that was kind of wordy. Here's what I mean. If I were to take the number 60 and try to split it apart into two factors, I like when they're even by just cutting them in half. 2 times 30 would give me 60, okay? Now, prime factorization means keep breaking down the non-prime numbers. So 30 is not a prime number. I can break that now down into 2 times 15. See where I'm going with this? I'm using a factor tree to keep breaking down the non-prime numbers. 15, excuse me. Still not prime. 3 times 5 would give me 15. And at this point, 5 is prime, 3 is prime, 2 is prime, and 2 is prime here. So the prime factorization for 60, and this is how I'd write the final answer, is going to be 2 times 2 times 3 times 5. Okay? And I'd like you guys to write it just like that, okay? Don't give me 2 squared times 3 times 5. Write it where everybody's expanded, just like that, okay? Number 2, what happens when there are variables at the tail end of the expression? Well, don't worry about the variables to start with. Let's just deal with the digit 112. In fact, let's just forget about the negative altogether. Well, like I said, 112 is even, so I'm going to cut that in 2, okay, because 2 is a prime number. If you want to check things on your calculator, 112 divided by 2 becomes 56. 56 is even, so I'm going to cut that in 2. I just happen to know that half of 56 is 28. Again, feel free to use a calculator if you need to. And then this is the point where that mental math is going to get a lot easier, right? 28 divided by 2 is going to be 14. 14, still even, divided by 2 is 7. All right, so this is the point at which we ask ourselves, okay, is everybody prime now? 2 is prime, and so is 7. Notice, by the way, too, none of the non-prime numbers made the final cut right here. So what do we do here? We replace now the negative 112 with 2 times 2 times 2 times 2, 4 of them, times 17. Now that gives me 112. How do I make negative 112? Well, I can put a negative 1 out front. That's how we take care of the negative, by multiplying by a negative 1. And then all I'm asking you guys to do with the variable expression here is to expand it. Okay? So to expand m to the 4 power, you just multiply by m 4 times. Expand the n's, that's going to be n times itself 3 times. And then there's 1p left over. So this right here is going to be the prime factorization of this. We call it a monomial because remember with polynomials, if it's one term polynomial, it's going to be called a mono. All right. Why don't you guys pause the video and try number 3 on your own? Try to determine the prime factorization for 143. All right, You guys give up on this one? All right, 143. This is kind of tricky. Since it's not an even number, it's not going to divide 2. Okay? In fact, if it doesn't divide 2, then it doesn't divide any even number. So when you're checking numbers here, 2, 4, 6, 8, 10, 12, ... already those don't work because 143 is not even. If it's not even, then it doesn't divide an even number. So I'm kind of free to check all the numbers that are not 2, 4, 6, 8, 10, 12. So does 143 divide 3? No, it does not. So if 143 does not divide 3, then that means it doesn't divide 3 or any multiple of 3. It doesn't divide 6, it doesn't divide 9, it doesn't divide 12, it doesn't divide 15. So it doesn't divide any of those. So I don't have to check 9 and I don't have to check 15 along with the evens. Does it divide 4? No. 5? Now, dividing by 5 means it has to end in a 5 or end in a 0. Like 5, 10, 15, 20, 25, 30. Notice they all end in a 5 or a 0. So since this doesn't end in a 5 and a 0, it's not going to divide 5 or any multiples of 5. So forget 5, forget 10, forget 15. Doesn't divide 6 because it's even. Does it divide 7? Well, that's a new one. Well, probably not because 14 divides 7 and 3 kind of looks like it's out there on its own. Right, this is like 20.42. So it doesn't divide 7 or any multiple of 7. Doesn't divide 14, doesn't divide 21. 8, we know it doesn't. 9, we know it doesn't. 10, we know it doesn't. Let's try 11. 143 divided by 11. Thank goodness. 143 divided by 11 equals 13. So if 143 divided by 11 equals 13, we have to take a look here. 11 ends up being a prime number. Prime means it only divides 1 and itself. 13 is also a prime number. It only divides 1 and itself. So there's no more breaking 143 down. 143 ends up being 11 times 13. Can't break down any further. Cannot factor further. All right. I'd advise you guys to pause negative 310 as well. See if you guys can do the prime factorization on that. It's our last example. Okay, let's check it out. I'm going to ignore the negative for a moment. It divides, it divides 5 because it ends in a 10, right? But it also divides 2 because it ends in a 0. So we know that 2 and 5 are going to be a part of this at some point. If I keep with my original strategy of dividing by 2 when it's even, I get kind of clunky numbers. So maybe that's not always the best idea. But here's what it would look like. We would have 2 times 155. And does 155 divide 3? No, it doesn't. But we know it divides 5. That would be the next prime number on the list. 5 times 31. And then 31. 31, if we try dividing by 2, doesn't work. Divide by 3 doesn't work. 5 doesn't work. And then we kind of run out of factors to check. 31 ends up being prime. So negative 310 is equal to 2 times 5 times 31. But we have to multiply by that negative 1 there too. And by the way, feel free to go off grid a little bit with something like this one. If you notice right away that this divides 10, you could say to yourself, hey, this is 31 times 10. And I know 10 is 2 times 5 right off the bat. You might get to the answer quicker by doing it that way. Same numbers, just a different order. By the way, at the end, make sure you put them in order from least to greatest. It just makes it more elegant, easier to read. All right, guys. Hey, I'm hoping this is going to be a simple lesson to start out our second bout of remote learning. Hopefully you guys feel the same way. Thanks for watching.